Hello, this is Radian Research, and today we're going to be making measurements and performing a burden test using our TX Auditor Transformer Analyzer. First, I would like to make my connections to phase A, and I'm going to connect current first. And to do that, I'm going to use the test switch and throw the safety bypass, and then open up my test switch. Then I'm going to use my test switch probe and insert in the test switch. I want to make sure not to insert the test switch too deep, as it might cause a current return on the back side if it actually hits the back plate. And then I'm going to unshunt my CT so that the TX Auditor is going to be seeing the current. Next, I want to connect to phase A voltage. Okay. And then phase A neutral. Okay. And then always I want to make sure I include my safety ground as part of my safety process. Okay, returning back to the screen of the TX Auditor, the measurements that we're going to be making are all related to the phase A of this service. I can see the voltage that I'm measuring is at 121.8 volts. Okay, the current coming from the CT is 0.1 amps. Okay, the phase angle for voltage and current is 30 degrees, and the power factor of that is 0.86. Okay, I can show my instantaneous watts being 10.69 watts, and I can show my VARs being minus 6.3 VARs. A nice measurement that we show on the TX Auditor is the total harmonic distortion for the voltage and the current. And the total harmonic distortion for the voltage is 2.25%, and the total harmonic distortion for the current is 2.1%. So in order to do a burden test, I'm going to first look at the CT and make sure I know what the burden rating of that CT is. This particular CT is rated at 0.5 ohms. I like to perform a burden test up to the rated plus 1 past it. And on the TX Auditor, to turn on the burdens, I'm going to turn them off real quick. You simply select the burden, and when it highlights white, it's turned on. Select the second burden, the third burden, and then 1.0 being 1 past the half ohm burden. So all 4 of those burden ohms are selected, and I simply select the burden button to perform a burden test. The CT that I'm actually testing today is a 200/5 rated at 0.5 ohm burden. Okay. The tolerance I put in for this particular test at 0.6% because I'm not at full load of the actual CT at this time. So the TX Auditor reports back our measurement of current at 0 ohms being 0.1 amps. And our 0.1 ohm burden test gives us 0.1 amps. And our 0.2 ohm burden test gives us 0.1 amps. And our 0.5 ohm burden test gives us 0.1 amps. And then again at 1.0. But what you'll see is the percent change value change. And what that percent change does is it's comparing the amount of current without burden, that's the I reference, and the amount of current with burden, that's the I burden. Now we're only showing 2 decimals of resolution here, so you can't quite see the subtle difference between the reference burden and the actual current with the burden applied. But the percent change does show us the amount of change, incremental change of those 2 comparisons. And in this case, all the values except the 1.0 burden, and even the 0.5 ohm burden are underneath the 0.6% tolerance, which is really good. And what a burden test is actually doing is we're trying to determine how much burden that might already be in the secondary loop of that test output of the CT. Okay? And in this case, everybody's passing underneath the 0.5 ohm burden, which is expected. So this is a great burden test. So that's doing burden testing with the TX Auditor. Any questions, visit radianresearch.com. Thank you.